Welcome to this second video on Tfactor. In this video I will talk in particular of right triangle and Tfactor. So we consider a generic right triangle having sides A, B and C. In the case of right triangle we have important theorem, that is the Pythagoras theorem, that says that square built on hypotenuse is the sum of square built on the other two sides, so the two legs. So c square is equal to the sum of square of A plus square of B. In a generic triangle we can calculate the area simply multiplying one side length by the altitude referred to that side. In the case of right triangle we can find the area simply multiplying the hypotenuse by the length of h, where h is the altitude referred to hypotenuse. So the area becomes simply ch divided 2, being this area ch is the area of a rectangle that is the double area of area of a triangle. The same way we can calculate the area of triangle multiplying the length of the two legs A and B divided by 2. We have the same result, and so ch halves equal AB halves, or in other words the product ch equal the product AB. So now consider both formulas, the one of Pythagoras and the one of area. The triangle factor is, as we know, defined by the sum of a square plus b square, triangle factor 1, function of AB, and divided by a product AB. This is the formula. This formula can be modified using the previous two properties. So we can replace a square plus b square with c square due to Pythagoras, and ab with ch. At the end we can simplify, and we have this important result that the triangular factor 1 is exactly the division of c by h. In other words, c, that is the hypotenuse length, is the product of a triangular factor by h. So c is proportional to h, and the constant to multiply is exactly the Tfactor 1. Being Tf1 bigger or equal to, as a result of a previous video, we have that the c is bigger or equal to by h. So in this case we have what we can call the theorem of double altitude of right triangle. So if we suppose that h is the altitude relative to hypotenuse c, this is altitude h relative to hypotenuse c, then the hypotenuse c is equal or bigger than the double of altitude h. Consider first the case of isosceles right triangle. In this case both legs have the same length. So A is equal B. Then C is a satellite double of H. And this is the case of half part of square of side A. So we have the right triangle sides A. So the C in this case is a satellite double of H. This is easy to see by geometrical property. If A is not equal B in general, then C is bigger than the double of 2H. So C is bigger than the double of 2H. Now we just make a small exercise where A, so we suppose A is a value assigned. So A is a value that we know. And we suppose that B is a multiple of A, with B is equal K multiplied A is 1. Also, C is supposed to be 5 halves times H. The value of C is consistent with the theorem of double altitude, being more than the double. We have to find the C, B, and K eventually function of A that is assigned. In this exercise, we accept K as only as natural number, 1, 2, 3. If we have K rational or irrational, that value will not be considered for this exercise. So B is defined as Ka. In the product AB, we replace B and we have AB is A square K. Tfactor is C divided by H, is 5 halves, and this is the formula. In this formula we replace A square plus B square and we replace in particular B using Ka here, and we put in evidence A square, and here we have S square K, and we simplify and we have this result. So 5 halves is exactly 1 plus K square all divided by K. We multiply both sides of equation by 2K. We have 5K equal 2 by multiply 1 plus K square. That, in other words, is we have to solve this second degree equation in the variable K. The solution is K equal 1 halves and K equal 2. We accept, as we said before, only result with natural number regarding K, and K equal 2 is the solution in our case. Replacing the value of K, we have B is the double of A, is 2A. Now we calculate H and C. The product AB is equal CH. So we replace B and we replace C. We have this value, this formula, and H square is equal 4 divided by 5 multiplied by S square. And the result is H is equal to A divided by square root of 5. Calculation of C at this point is easy. 5 albs multiplied h. We replace h here, and we have this result. C is square root of 5 multiplied a. So solution is b equal to a, k is equal to h, 2a divided by square root of 5, and c is square root of 5 multiplied a. Thank you very much for watching this video. I hope that we can see again in a next video. Thank you very much.